Now, for the third one is called the normal reaction force. The normal reaction force. We use a symbol capital R for it. A normal reaction force is the force that at surface acts on an object. Surface. What surface? The answer is any surface. Any surface that the object is in contact with. For example, let's say I'm sitting right here, right now. So the surface, one of the surface that my body, let's say I'm treating myself as an object, the surface that my body is in contact to is the chair, okay? But when we talk about the surface, it's only the surface that is in contact with. So when I say that, oh, the normal reaction force is the force that the chair pushes on me, it means that it's only the part of the chair right below my butt that is pushing me. Or if, let's say, I'm standing up. Maybe I'm standing on a ground like this. Boom, boom, boom. So, of course, the places where me in contact with the so-called surface is my feet. In this case, the surface, it's not the entire earth, but it's going to be only the surface right below my feet, okay? Which is unlike the weight. The weight is the force that the entire earth is pulling me down. But the normal reaction force is only the surface part of the earth right beneath my feet that is pushing me, okay? So you need to be careful is whatever point that the object is in contact with the surface, there will always be the normal reaction force. Now, there could be more than one. Like for example, I'm sitting here and maybe I'm just like leaning back as well. So there is a force from the bottom of the chair pushing on, well, my bottom up. And also there is going to be from the back of the chair pushing me as well because I'm in contact with them. So the point here is whenever there is a contact between an object to a surface, there is a normal reaction force. But the important bit further is the word normal. Why does it call normal? Or basically, what is so normal about this force? Or what is so abnormal about other force? Now, the usual answer that I get for it is they're gonna answer that, oh, because the force is always there. But I mean, of course, like the weight is always there, the tension is always there, but you don't call it normal. And the answer is normal. Doesn't mean normal. Okay. Normal doesn't mean normal because, okay, at least it doesn't mean normal in a typical sense. Like it doesn't mean typical, it doesn't mean like it's always there. No. Normal here means normal in the math. Normal in math means perpendicular. So this is saying that the direction of the normal reaction force is perpendicular. But perpendicular to who? Obviously, the surface. So when we draw this, we draw it perpendicularly outward from the surface. Okay, we draw it perpendicularly outward from the surface. So for example, let's say I have a floor. I put a box on it. Okay. So there is a normal reaction force on the box. Since it's coming from the surface, I need to indicate the point from the surface right there. Since the surface is horizontal, I need to draw it vertical. In this case, boom, it's going to be vertically upward because it's the force pushing out. Okay, the key is pushing out from the surface. A lot of people make mistake because if you try, let's say if I try to draw the weight as well, a lot of people think that the normal reaction force is the opposite of the weight. Or even worse, they say that it's always equal to the weight, but it's just opposite direction. No. Very, 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 very wrong. Okay? When we talk about common forces here, these forces are different forces. There is absolutely no relationship between them. At least there is no intrinsic relationship. Like the weight is a weight. Normal reaction force is normal reaction force. Completely different thing. Completely different rules. Whether they are equal but not equal, it depends on scenario. It depends on the situation now. Okay? Basically they are not always equal to one another. The relationship between the force, whether this is equal to that or this is greater than that, will be given by the Newton's law, which we're going to learn next. But for now, when we look at the force, when we write the force, when we draw the free body diagram, we just list them. We don't know whether they are equal or not. Okay, so be careful. They are not always equal, and the normal reaction force and the weight are not always opposite as well. Okay, the rule for normal reaction force is that it's always perpendicularly outward from the surface. So, for example now, what if I have an incline and I put a box on an incline? Let's say like this. If I do that, if I try to draw the normal reaction force, again, draw from the surface, so a dot is at the contact point, perpendicularly out from the surface, kind of like that way. Label it R, okay, capital R. So the key is normal reaction force is not always upward, it depends on the surface.